We're on our way to this point that marks the beginning of spring. The planets accompany us around the sun, but at different speeds. We can see only the ones that are well out of the sun's way. Mercury and Venus are often hidden by the sun's glare, and so is Jupiter far away on the other side of the solar system. Looking from the Earth, when Jupiter is lined up with the sun, we can't see it. However, when Saturn, at the bottom of the screen on the left, is at an angle well clear of the sun, we can see it all night. The same goes for Mars, the red planet, in opposition here facing the sun. Looking from the Earth, we can use the backdrop of the zodiac to get our bearing. The zodiac is an imaginary band holding groups of stars or constellations visible in the distance behind the planets. Planets remain invisible when they pass in front of the same constellation of the zodiac as the sun. Here in Capricorn. During the day, we can't see them because they're too near the sun. And when the sun sinks below the horizon, well, they disappear under the horizon too. At night, planets at a wide angle to the sun are very visible. The Earth continues on its way, and the sun seems to move across the zodiac. It passes from Capricorn into the constellation of Aquarius. On the right, Mars, the red planet, moves more slowly than the Earth. Every 2 years we catch up and overtake it. On the left is Venus, traveling faster than us. Mercury, the nearest planet to the sun, moves twice as fast as Mars. The closer a planet is to the sun, the faster it revolves around it. A long way from the sun, the outer planets travel slowly around their orbits: Jupiter, Saturn, Uranus, Neptune, and Pluto. 400 years ago, when the telescope hadn't yet been invented, a Danish astronomer, Tycho Brahe, measured the transit of the planets. Tycho Brahe set up a large panel, and night after night he recorded the hour and minute when the stars and planets passed behind his panel. In the Middle Ages, the Earth was thought to be at the center of the universe. Then Nicholas Copernicus had a stroke of genius. The Earth isn't at the center of the universe. The Earth and the planets revolve around the sun. Tycho didn't believe him, but fortunately, he showed his records to Johannes Kepler. Their meeting changed the world. Kepler knew Copernicus's theory, and using Tycho's measurements, he was able to work out the movements of the planets. The planets do revolve around the sun, but in elliptical orbits. The Earth and the planets move faster when they're near the sun, and more slowly when they're far away. It takes the same time to cover the long distance on the left as the short distance on the right. The short, wide slice is equal to the long, narrow slice. Kepler's discovery helped us choose the right path to travel to the Moon and Jupiter. Our calendar also depends on Kepler's laws and the variable speed of the Earth. The nearer we are to the sun, the faster we travel. This changes the timetable of our journey around the sun. Now we're slightly nearer the sun. The Earth accelerates and gains a little ground. But in the summer, further from the sun, the Earth slows and drops back. The spring equinox is on the 20th of March, and the autumn equinox on the 23rd of September. The Earth reaches the autumn equinox 7 days late. To cover this summer half of its orbit, the Earth takes 7 days more than it does to cover the same distance in this winter half. So Kepler's law is no abstract notion for astronomers. It directly affects our calendars. At the moment, we're here, ahead of schedule. Roughly every 2 years, Mars doesn't follow the movement of the other planets. It begins to move backwards. Normally, Mars moves forward against the backdrop of the zodiac. We can see Mars moving in front of the constellations of Gemini, Cancer, and Leo. and heading towards Virgo. But here, instead of moving in line with Virgo, Mars returns towards the constellation of Leo. In the days when men thought the Earth was at the center of the universe, they'd already noticed the loops made by Mars and constructed complicated theories, but they failed to explain this reverse motion. Nicholas Copernicus's theory explained everything in the simplest way. The Earth revolves around the Sun like Mars, but the Earth travels faster than Mars and overtakes it. When it does so, Mars seems to move backwards against this backdrop of stars. After 2 months, Mars returns to its usual motion, which has really never changed. After 2 years and 2 trips around the Sun, we meet up with Mars again and overtake it. Little by little, the Earth catches up with Mars. When it begins to overtake the red planet, Mars shifts into reverse in relation to the stars of the zodiac. Then overtaken, Mars moves forward again. Thanks to Copernicus's discovery, Mars revolves around the Sun with no loops. Each month, when the Moon revolves around the Earth, it lines up with the Sun. This is the new Moon. The new Moon brings us tides. The water in the oceans is pulled by the Moon to form a high tide bulge on the lunar side. Each day, the Moon passes 50 minutes later than the day before. That's why the tides happen 50 minutes later each day. When the Moon lines up with the Sun, they pull together, drawing the water in the same direction. This is the spring tide. But why are there 2 tides a day when the Moon only passes once? The Earth's center of gravity isn't in the same place as the center of gravity of the Earth-Moon pairing. The first tide on the lunar side is caused by the pull of the Moon. At the same time, on the other side of the Earth, there's a second tide caused by centrifugal forces. What's more, the Moon's orbit is an ellipse. Sometimes the Moon is near, sometimes it's farther away. The nearer it is, the stronger the tide. And when the Moon's closest approach to the Earth coincides with the new Moon, it gives us the strongest tides of the year, sometimes even stronger than the equinox tides.